Let's welcome, all the way from Brazil, Zabbix trainer from Universidade by Salbetti, Paulo Roberto Deolindo Jr. Welcome.
Thank you. Good afternoon, everyone. I'm glad to be here again. This is my second time in Riga and Zabbix Summit as well. So I'm very happy and, to be honest, some nervous too. So be patient with me. Today I will talk to you about monitoring, detect, actually analyze, responding, finding, learning with incidents, security incidents by using Zabbix and cool integrations such as Suricata and MISP. In the end of the presentation, I have some surprises for us. Before I start, let me introduce myself very quickly. My name is Paulo Deolindo. I'm a Zabbix trainer by Universidade by Salbetti in Brazil. Let's talk about the problem we are trying to solve here today. Most companies I know are treating cybersecurity subject as a secondary concern, and as we know, it's a big mistake. Some of the problems these companies can get, in the best of the case, some can be, let's say, successful network scans, successful cyber attacks, in the best of this case. But in the worst, let's think about negative impact with considering laws and regulations. So data breach are very, very bad for us. What we are proposing right now, integration by Zabbix with two different sources of threat intelligence. In this case, Suricata and malware information sharing platform, as we see soon. In the final of this presentation, we'll be able to see Zabbix as a part of a security operations center, not a unique and absolutely solution, but part of the interesting stack. A simple question I like to ask for customers. Any thoughts about scans? I can wait about 5 minutes, of course, this time is estimated, but sometimes I can wait 10 seconds and have no answer, so I already had my answer. Probably they have no idea. So let's take a closer in a basic design proposed for this scenario, for this presentation here. On the right, we have some running parts. In this case, some basic Linux running web server, FTP, SSH, SNMP, whatever you want. And real time, they are mirroring their network traffic to a special deployment. This deployment in the middle of this shape is a Zabbix proxy and Zabbix Agent 2 to read Suricata logs, and of course, Suricata. In this case, Suricata wasn't installed in endpoints directly, but strategically somewhere on the network topology. Okay, so Suricata will receive these logs, read, analyze each of them. Zabbix H2 will read these logs, and Zabbix proxy will send data to a Zabbix server. Now, Zabbix server will research in malware information sharing platform, searching for IOCs, indicator of compromise, based on the source attack from source IP from the attacker, and at the same time feeding MISP about the remaining attacks. So, kind of two-way. I can research and feed MISP at the same time. It's a nice thing to do. And then Zabbix will perform trigger evaluation based on the reliability score What's the reliability score? Reliability score is a custom metric created in this scenario by a calculated item with Zabbix, considering something like a BuzzIPDB confidence score. That's right. So, based on it, we have a kind of double or triple check, and our Zabbix will decide if this trigger will be fired or not, and then perform another calculated items, such as baseline monitoring, anomaly detection, learning about behavior of the environment, and then, one more time, decide if the source IP must be blocked at the source or not. The last but not least, we have IRS, the FAR tool for forensics investigation. It's not about Zabbix and is integrated in the solution, but not our focus today. Now, very quickly about Suricata. Basically, Suricata is intrusion detection and prevention system and much more, but for our case today is categorizing some kind of traffic in normal and abnormal traffic. Basically, normal traffic will be recorded in EVJSON log file and only alerts logs in fast log. Unfortunately, we can make something about it later. Alert logs will be recorded in EVJSON log too, because alert is a kind of event. Normal events, alert events. Okay, but fast log, it's only for alerts. Okay, reading Suricata logs, as you can see, a sample of EVJSON log. We have not standardized logs because it will depend on the event type. As you can see, a log line size, a log line field, a log line with piece of information can be dynamic, depending on the event type. But on the other hand, we have a fast log. So it's more easier because it's a standardized log. So I can apply some regular expressions and retrieving, extracting data from these logs, such as timestamp and so on. Of course, it's simple. You can build your own regular expressions. I'm not a specialist in it. And finally, we have our first result. We have a master item, in this case, a log file monitoring, a recording, or do not store nothing in this case, because we have 10, at about 10 new items based on dependent items, because we applied pre-processing steps with regular expressions to extract information, and then finally display data in item history widget, a very nice implementation since Zabbix 7, I think. And here, as you can see, we can count the number of alerts considering a minute, an hour, and so on, and displaying the same data considering time shift, going back to the time, a day, a week, a month, whatever you want. And in this case, if you consider the current hour and the previous one, you can create something like an hourly percentage change, but you can consider in this same logic for weeks, days, months, and so on. And about normal events, because if I'm monitoring only alerts, everything I will see are problems, that's right? So my environment is terrible. No, maybe not. And about normal events. So I can read EVJSON log, that complicated and dynamic log, excluding alert logs. And then, by a calculated item, I can retrieve or generate another metric I called alert rate. Based on it, back to machine, um, 3 years ago, I was here talking about anomaly rate, baseline monitoring, and now it's applicable again. But I'm looking at behavior of the entire network, not based on net flow this time. And finally, I can focus on attackers discovery. Thanks God, Kasper's explained very well previously about low-level discovery rules, so my job is easy now. Let's imagine this. Based on the source IP attack, retrieved by a dependent item, I can build some low-level discover, applying preprocessing with CSV to JSON conversion, and create some host prototype, and then create hosts representing the attackers, applying some basic geolocation templates to retrieve latitude, longitude, and then we have a geolocation from the origins of the attacks. Don't pay attention with this one right now. It's a second template from a host type based on MISP, as we'll see soon. What is MISP? MISP, as I said before, is a malware information sharing platform. Basically, I think the most used in the world for threat intelligence. So I can get my MISP, install, configure, enable some feeds, and synchronize them with the entire world, and vice versa. And here, just to show you, I'm conducting manual research in front end of MISP. Based on the source attacker, I can search for a kind of IOC, IP, DST, and here MISP is reporting how many events someone report about this attacker. So I think he's a very bad guy. Huh? But Zabbix has your own way to do it by using HTTP agent and consuming MISP API, retrieving basically the same data. But this time, I will apply some JavaScript preprocessing to retrieve two essential metrics: the number of total events reported for someone about this bad guy, and another one about the same number, but with flag 2IGS, indicating if this guy can be blocked, must be blocked or not. So I must be, or I must be, I don't know. So, reliability score. Okay, I can create another calculated item to retrieve this metric, and then help Zabbix to evaluate with your trigger this one. My trigger prototype is a simple, not elegant trigger like Alexander's triggers previously, but here we already have something like a double, triple check, because I'm based on the threat intelligence from Suricata and the threat intelligence from MISP. So it's a very simple evaluation, and we can forget, can't forget, sorry, about these tags and LLG macros, because the next step will be incident response. Basically, in this case, I'm using 4 custom scripts to respond to the incidents. The first one, to block the source IP based on the threat intelligence, as I explained before. Feed MISP about the remaining attack. Send some alerts to the far iris if you prefer the Hive and so on, but in this case, the far iris, because Zabbix is not a trouble ticket system, so I have to open some alert for security analyst, and then finally close the problem by using Zabbix API in this case. Okay. I had a problem in the beginning in this scenario because I was delaying the incident response in 1 minute. Who have an idea that happened with me? Because the number of the attacks in an organic scenario, the escalators were crazy. Have no escalators, 100% busy. So, to reduce MTTD, time to detect and time to response, no KPIs in cybersecurity, let's execute immediately, and here we have a little video to show in real time. In this case, Zabbix is blocking in real time in those 3 honeypots, the source IPs, and at the same time running those 4 scripts, generating some tracks. And if you observe the time of the duration of the triggers, the events, we see something like MTTD, MTTR. This is MISP. It's not about Zabbix, but a very nice tool to investigate incidents. It can be very, very helpful. Let's go ahead. So, another result from this scenario, feeding MISP. Every time I'm attacked, I'm feeding MISP. So, if this bad guy come again in the future, the reliability score will increase and increase and increase, and someday I think he will be a not guy anymore. Okay. So, how much time I have? 2 minutes. I'd like to introduce a shuffle, a nice tool to offload Zabbix. Basically, the structure will be the same, but now Shuffle will perform blocks and feeding MISP and open alerts on iris and in about Zabbix. Zabbix will focus on specialized Zabbix features, baseline monitoring, data analysis, anomaly detection, and amazing features since Zabbix 6 for data analysis. Here we are. The same flow, but making Zabbix a part of the SOC stack and not an entire tool for do everything. That's right. So, the track of the executions, offloading Zabbix, and now Zabbix will can focus on the specific scenarios. Okay, to conclude, Zabbix can perform incident response. Be careful with Zabbix resources. Like I said before, escalators can be crazy if you delay and have some too much triggers to close and analyze. Oh, sorry. Extend Zabbix with threat intelligence. Shuffle can offload Zabbix. Zabbix can focus on machine learning, for example, and focus on analysis, as I said before. Sorry, I'm quite nervous. So, this is it. Thank you so much.
So we have one quick question. Why you chose Zabbix to integrate all of this with? Because you had Zabbix and then you needed to integrate with Zabbix, or because Zabbix was the best fit over here?
It's easy to choose Zabbix because by using Suricata for this scenario, we can get something like a John based on threat intelligence and MISP too. But if you think about Suricata, Suricata is a backend. So to read Suricata data, if you enter in Suricata website, for example, will be another tools to analyze data. Why not Zabbix? Zabbix is very smart to do data analysis and can contribute a lot.
Thank you.